Hi everyone, I'm Soumya, a software engineer and an educator. Welcome to module 2 of the Kotlin crash course. In this module, I will teach you in detail about object-oriented programming in Kotlin. Classes and objects in Kotlin. Kotlin is an OOP language, object-oriented programming language, and it is a paradigm which allows us to solve problems with the help of objects which represents the real world entities. This is object oriented programming language, and in such languages object play very significant role, and classes and objects are kind of integral part of such programming languages. So if you talk about classes in general, so class is a blueprint or a template, you can say, and objects are the real thing. You create objects in your program and they interact with each other to complete the work. This is a bit of theory and might be right now you are not clear of what exactly class is, what exactly objects are, right? So I'll give you some examples and that will help you understand things in way better manner, okay? So if you see this picture, it contains mobile 1, 2 and 3, right? And all these are different in terms of their size, color, battery type and features, right? Might be this is phone from MI company, Oppo and so on, right? But can you imagine what is the general thing about all these three types of phone? So yes, all these three are mobile phones, right? If we want to put all of these in one category, we can say mobile phone, and these three, the Oppo phone, MI, all these are mobile phones, cell phones, right? So if we have a class of mobile phones, then we can have objects 1, 2, 3 which are of different companies, right? So this is how the concept of classes and objects are. To make it more clear to you, let's say if you have a class of car type, then inside this you can have multiple objects, right? You can have object of type Ford, you can have object of type BMW, you can have object of type Tata, etc. I mean, so many cars are there, right? So yes, I mean, that's how the concept of classes, and inside that objects, all the objects will be somewhere related to that class. Like all these are related to this class mobile phone. These all are mobile phones only, right? In the same way, all these objects, object 1, 2, 3 are of the same type. They are car only, but obviously the features, the color, everything will be different, the price and all those stuff, right? Perfect. So before you create objects in Kotlin, you need to define a class. A class is a blueprint for the object. We can think of class as a sketch or prototype of a house. It contains all the details about the floors, doors, windows, etc. Based on these descriptions, we build the house. House is the object, okay? Since many houses can be made from the same description, we can create many objects from one class. Might be in two objects, the only differences of color, they are all same, but they are of different colors, right? Perfect. How to define a class in Kotlin? Now let's see the syntax of classes in Kotlin. Very important. So we use the keyword class, okay? We use the keyword class, and after that class name based on your need. Let's say if you are creating a class for car, you are creating a class for people, for objects, anything for that matter, right? So class keyword, this is keyword, and then this is the name of the class, right? And then inside this you can have multiple properties, you can have member functions, you can have variables. Like for people class, you can have name as one of the variables, age, gender and so on, right? Awesome. So I hope the concept of class is a bit clear to you now, right? You would have got a basic overview or of idea of what classes are. If car is a class, then you can have objects like BMW, Ford and so on, right? In the same way, if you have person as the class, you can have multiple objects, object person 1, person 2, and so on. Awesome. Here is an example of the same. This is class lamp, and inside this you have some member functions as well as some variables, right? So this is var is on. This is of type boolean. Private is the modifier, visibility modifier. I'll talk about it shortly. So var keyword you already know. Is on is a variable, and we have given the value false to it. So lamp is on a kind of variable which tells if the lamp is on or off, right? True means is on, false means it is not on. And then we have member functions as well. We have turn on function. So obviously if you'll call this function, then the lamp will be turned on. If you will call turn off function, then the lamp will be turned off, right? Perfect. So here we defined a class named lamp. The class has one property is on, defined in the same way as variable. Obviously we just saw this. And you have two member functions as well, turn on and turn off. These two are the member functions. These two are functions. And here we have one var, one variable. Alright, moving ahead. Classes, objects, properties, member function, etc. can have visibility modifiers. Obviously, like we just saw private here. Private, by default they are public. So for example, the is on property is private here. This means the is on property can be changed from only inside the lamp class. That is, that variable is private, that can only be changed from inside that class in which it is created, in which it is declared. Other visibility modifiers include like private, obviously you just used, visible from inside the class only, public, visible everywhere, protected, visible to the class and its subclasses as well, internal, any client inside the module can access them. So you will understand more about these modifiers, etc. once you will start writing code, more and more code, right? So if you do not specify the visibility modifier, it will be public by default, as I just told you. And in the above program, turn on and turn off member functions are public, whereas the is on property is private. So basically they are saying is on property is private, but these two member functions, turn on and turn off, are public because we haven't given any visibility modifier to them. Now let's talk about Kotlin objects. Before that, I hope you remember the syntax of classes. Basically you just have to do like this. A class keyword will be there, and then the name of the class, name of the class based on your needs. And inside this you can have data members, or you can call them data variables. And apart from that, you can have data functions as well. Moving ahead, let's now talk about Kotlin objects. When a class is defined, only the specification for the object is defined, no memory or storage is allocated. So we just created this class lamp, right? So when the class is defined, there is no kind of memory or storage is created for that class. If you want to access the members, defined within the class, like is on or turn off, if you want to access these, you need to create objects, okay, objects of the class. And the syntax is pretty simple. So you know that this is the class, okay, class lamp. One second, yes. So this is the class lamp till this point. This is main function. Whenever I'll compile the program, so the compiler, what it will check, it will first of all check the driver function, that is the main function. Now if you see the first piece of code here, first line of code here, number 1, val, which is a keyword, L1 is equal to lamp. Basically here I created L1 object of lamp class. Okay, what it will do is it will create some storage for us. I mean, if I want to, let's say, access the property is on, so I can say L1 dot is on, If I wanted to access, let's say, this function turn off, so turn off, something like that, using the dot operator, this one is called dot operator, I can access the data members and the member functions inside the class. Okay, awesome. So this is the way we create the objects, val or var, anything, name of the object, object1 to whatever you want, and after that the class, whichever class you want to call, something like this, like lamp. Okay, this program creates two objects, L1 and L2 of class lamp. The is-on property for both the lamps will be false. The is-on property for both the lamps L1 and L2 will be false, because obviously in the starting, while we created the class lamp, we set the value of this variable is on as false. Moving ahead, how to access members, I already explained you. You can access properties and member functions of a class by using the dot notation, dot operator. For example, L1 dot turn on, this statement calls turn on function for the L1 object. Let's take another example. So L2 dot is on is equal to true. So basically what we are doing is we are calling the is on variable from the L2 object, and we are setting its value as true, because initially it was installed as false, right? So here we try to assign true to is on property of L2 object. Note that is on property is private, and if you try to access is on from outside the class, an exception will be thrown, right? Now here is an example of Kotlin class and object again. So this is the same example. If you see, so this is the content of the class lamp. We have turn on function, we have the turn off function. Apart from that, we created a new function, that is display light status, right? Depending upon, like, we'll pass some string variable, and then we'll check if is on is equal to true, then it is on, otherwise it's off. So here it's important to understand what we are writing. Okay, let's see. So function main is the first thing to be executed when the compiler runs a program, right? So val L1 is equal to a lamp. Basically we created L1 object of lamp class, and then we have L2 object of lamp class. So L1 dot turn on, we are calling L1 dot turn on, so it will go and do this, is on is equal to true. So for L1 the value of is on is true, right? So when I will do L1 dot display light status, so is on is true, so it will print that this lamp is on, right? L1 lamp is on. And for L2 I am calling turn off, so the value of is on will be false, and therefore when I'll call display light status by passing the L2 object, then obviously is on is not is equal to true, so it will print lamp is off. Perfect. It's very simple. I mean, behind the scenes also is very important to understand. So let's say when you are creating an object like Mustang, Beetle, anything for any of these classes, like if the class name is car, so as soon as you create the object, memory is given, memory is allocated to the particular class, depending upon how many member functions, how many variables are present in that particular class. And let's now write some classes, some objects in Kotlin to understand this concept in even better manner. Perfect. So now let's create a class of name. Maybe you can create my class, in which we will create objects and classes and see the syntax of classes and objects in Kotlin, right? So I'm going to create new, and here is Kotlin class in file. I will name it my class, and it should be of type file. Then I'll write function main, because obviously main function is the most important thing. I mean, whenever you will click this green run button, so main function is the first thing which the compiler executes, right? So here we will create object of the class, we know the syntax very well. Before creating the object of the class, obviously the very first thing is we have to create the class itself, right? So the syntax of creating class is very much simple and straightforward. You have to use the keyword class, and after that the name of the class. So right now I want to create a class of name person, and here what you can do is, like, we in the syntax read that we can have curly braces, right? And inside the curly braces we can have data variables, we can have member functions and like variables as well as functions, right, of that particular class. So here if you see, I can have curly, simple parenthesis as well, and inside that I can pass on values when while creating the object of the class, right? So what I will do, I have the person class. So person class can have variables like name of the person, age of the person, gender of the person, and so on, right? So let's say I want to create a variable name, okay? So var name, which should be of type string, okay? And after that var age, and that should be of type int, and so on. You can create multiple variables here, right? Name, age, and depending upon the person class, what kind of variables, member functions it can have, you can go on and on, right? These are the properties, the data variables, and you can create these inside the class as well. But for the ease, I passed these here itself. Just in next few minutes I'll teach you why I did that and why it's important in Kotlin, and how it's related to the concept of constructors as well, okay? Perfect. And here I will create one function, can vote, okay? Can vote, can vote, and I will accept the age variable, the parameter. And inside this I'll check if age is less than 18, then I will print here, I will print cannot vote. Else if the age is I can simply go on writing else. If the age is greater than if it's less than 18, then cannot vote. Otherwise print ln, I will say can vote, okay? Can vote. Awesome. So I have the person class ready, and inside that I have one function can vote, and the two properties, two data members are name and age, okay? Either you can pass these variables inside the person class, or the way I have done it in the parenthesis as well. So I'll create object of the class person. So var object1, or you can say person1, so obj1 is equal to person, and here I have to pass some properties, right? So the first name I'm giving here Soumya, and I'm giving here age 22, okay? And after that, to call other member functions, variables, I'll say object1 dot, you can see here I have multiple options. I can call name, age, or can vote. So I want to call can vote, and I'll pass here 22. So if I run this piece of code, you will see that it will print can vote. Why? Because the age passed here is 22, right? 22. So what it will do, it will call this function, and it will check here if 22 is less than 18. It is not less, so we'll come here and print can vote, okay? So it's as simple as it looks. Creating a class, the syntax is very simple. The class keyword is their name of the class. Inside parenthesis you can pass some variables, and you can do the same thing like after creating the class person, and inside like function can vote is here, right? So you can similarly have some variables here as well, name and so on. So it depends on you. I did it because I wanted to pass values here via the object only while creating the object. It looks better. I mean, depending upon the use case, you can change the way you create the class, you can change the way you create the objects, and so on. And now let's get back to the iPad, and I'll teach you some more important concepts around OOPS, around classes and objects. So now let's talk about constructors in Kotlin, yet another very significant concept, right? So Kotlin constructors. A constructor is a concise way to initialize class properties. Like I just now created the person class, and inside that I had properties like name, age, can vote, etc. So if I want to, let's say, initialize the values like name, age, and there can be like multiple values. So for those, constructor is very important. If anyone asks you what are constructor, so they are very handy. They are concise way to initialize the class properties. It is a special member function that is called when an object is created, when the object is instantiated. However, how they work in Kotlin is slightly different. In Kotlin, there are two types of constructor: primary constructor and the secondary constructor. So talking about primary constructor, the primary constructor is part of the class header itself. This is a good example here: class person, and then we have variables here, first name and age, and this is the class body. So the block of code surrounded by parentheses is the primary constructor itself. This much block of code, this much piece of code which is surrounded by the simple parenthesis, that is primary constructor in Kotlin. Okay, so I just created the similar kind of class, right? So in that, the class header itself is containing the primary constructor, right? The constructor declared two properties: first name, read only property, as it is declared using the keyword val. Okay, and then we have age, that is read write property, since it is declared with the keyword var. I hope you remember var and val, which I taught in the starting of the course in module 1, right? So this is again example of primary constructor. Function main is here. I created person1, the object of the class person. I passed Joe 25 as the value of the parameters first name and age, right? So here I am trying to get the value of the person and the age as well. So person1 object dot first name and object dot age, it will print the value of the variables, right? Perfect. Primary constructor and initializer block. So the primary constructor has a constrained syntax and it cannot contain any code. So as you just saw, the syntax of primary constructor is quite like restricted, kind of. Only this much part, I mean after the name of the class, in parenthesis you can pass parameters. That is the primary constructor. It is in the header of the class while creating the class. So it cannot contain any code, we just saw. To put the initialization code, not only code to initialize properties, initializer block is used. It is prefixed with init keyword, and if we try to modify the above example, so it will look something like this. Function main, right? We created one object person1 for the class person, and we passed two values. So here we passed Joe and 25, right? Then I have first name and age as the data member for the class person. Then I have initializer block in it, and inside this what I am doing, I am initializing the first name. You can see here first name is equal to fname dot capitalize, and then age is equal to person age, whatever we are passing here. So the value of first name will be like, if assume this is the value, so Joe in capitals because we are capitalizing here, and 25, right? And if you print here, so obviously you will get the value which we passed, right? Perfect. So I mean it is the example of initializer block in it. If you want to initialize something, not only initialization, but you can do much more than that. You can use init block, because we saw that the kind of freedom given to primary constructor is quite constrained, right? So you can use the init blocks as well. And moving ahead, when you run the above program, the output will be first name Joe and age is 25. Age is 25. So here parameters fname and person age, inside the parenthesis accepts value Joe and 25. Obviously these fname and person age, they accept the values which we pass from here, right? And after that, when person1 object is created, however fname and person age are used without using var and val, they are not properties of the person class. They are not properties of the person class. The person class has two properties, first name and age, as declared here inside the class person. And when person1 object is created, code inside initializer block is executed. So if you ask when this init block is executed, it is executed as soon as you create the object of the person class. When a person1 object is created, the code inside initializer block is executed. The initializer block not only initializes the property but also prints them. Okay, but also prints them. So I hope the concept is clear now. The f name and person age inside the parenthesis, that is this one, they accept the value that we passed from here while creating the object, and when the object is created, it executes the init block which is here, right? Awesome. And here is another way to perform the same task. So we have the function main, and in this we are creating person1 object which is of type which is for the person class, right? And we are passing two values here. And if you come here, you can see f name and person age, they are here to accept the values that we are passing while creating the object. And here first name and age, I am initializing them. Inside init, I'm just printing stuff. To distinguish the constructor parameter and property, different names are used, like f name and first name, person age, etc. It's more common to use these kind of variable names. So when you will run the program which is written here, so output will be something like this. And when the object of the person class is created, Joe and 25 values are passed as if the person is a function. And that's the beauty of classes and objects in Kotlin. Like here we created the class in the way a function is created, right? And that's why it was able to accept the values when we passed while creating the object. The same thing is written here. This initializes the first name and age properties of person1 object to Joe and 25 respectively. Moving ahead, primary constructors, they are very simple and easy to understand. They're kind of inbuilt. In the class header only the primary constructors are there. If we talk about Kotlin secondary constructor, so in Kotlin a class can also contain one or more secondary constructor. They are created using the constructor keyword. Secondary constructors are not that common in Kotlin. They are not heavily used, but yes, it's important that you understand what are Kotlin secondary constructors. The most common use of secondary constructor comes up when you need to extend a class that provides multiple constructor that initializes the class in different ways. So here you can create a secondary constructor in Kotlin this way. Here is the syntax. So let's say the class name is log, right? If you want to create secondary constructor, use the keyword constructor, and then you are passing one parameter, then constructor keyword, and you are passing two keywords here, parameters here. Here the log class has two secondary constructor but no primary constructor at all. You can extend the class in this way. If let's say class log is there, it is having two constructors, right? You have auth log, another class which is inheritance is basically going on here. It is inheriting from log class, right, which is created here. So you can see that can inherit the constructors as well from the parent class. Here the constructors of the derived class auth log calls the corresponding constructor of the base class log, and for that super keyword is used here. As you can see, super keyword is used, right? So secondary constructor in Kotlin is not that heavily used, very less, and to create you have to use the constructor keyword. That's it. Apart from that, primary constructor are very common, and you just saw multiple examples of it. It's kind of primary constructor. It is one of the concise way to initialize the class in Kotlin, and the syntax you understood already. Moving ahead, by now you know how to create class in Kotlin, how to create objects, and when objects are created, then only some storage is allocated, right? And you can call the data members, the member functions of the class using the object only. What are constructors and types of constructors in Kotlin. Moving ahead, let's talk about Kotlin getters and setters. So in programming, getters are used for getting value of the property, and similarly setters are used for setting the value of the property. If I want to, let's say, set the value of some variable to maybe scalar, right? So I can simply do that with the help of some syntax, and that's what we are going to see, what are getters and setters in Kotlin. So in Kotlin, getters and setters are optional and are auto generated if you do not create them in your program. So if you do not create them in your program, they will be auto generated, right? So how getters and setters work? The following code in Kotlin, if you see. So class person and var name, we are creating a variable of type string and we are giving it default value, right? This one is equivalent to this piece of code. Class person, we have name variable of type string and we have some default value here. So if we are not creating getter setter, by default it is being created there. If you see here, get is equal to field getter and setter in this way, set value and field is equal to value. So if you write this much piece of code, you can assume that getters and setters are by default created in the background in Kotlin. Example, let's understand this one. Quite lengthy piece of code, but it's very very simple. I mean, nothing difficult is there. Whenever you feel that any piece of code is difficult, just start executing it, start doing dry run of it, and it will become very very simple for you to understand. So obviously fun main, the compiler will start from here. Val Maria is equal to girl. So basically what we are doing here, we are creating Maria object for the class girl, right? Maria dot actual age is equal to 15. So I am calling the actual age parameter. So let's see how many parameters are there in class girl. So age is there and then actual age is there, right? For age we have written some piece of code, getters and setters, right? So here get is equal to field and set is equal to value and field is equal to 18 if value is 18, otherwise something like this, right? Now they have written a lot of getters and setters code, right? So let me erase this and now let's see here. So Maria dot actual age is 15. So if I'll print this, obviously I should be getting 15 and I'm getting 15 only, right? I'm getting 15. But if you see here, Maria dot age is 15 and for age I can see I have getters and setters available here. So it is doing some change here. If value is less than 18, so for me it is less than 18 only. So it is saying that field is equal to 18. I mean, it is changing the value, and that's why when I am later on printing Maria dot age, I am getting 18 as the output. 18 as the output, right? Same way, let me again do a dry run of the other piece of code that will help you understand better. So here what I am doing is I am creating Angela object of type girl, right? Angela dot actual age is equal to 35. I'm calling actual age and I'm setting its value as 35. So when I will print it, it should give me 35. It should give me 35, right? This much part is clear. After that, Angela dot age is equal to 35. But here if you see, 35 will be passed, right? So if value is between 18 and 30, this will be the case. Otherwise I will fall in this case because the value here is 35, right? And 35 is neither less than 18, it is neither between 18 and 30. So obviously this piece of code will be executed. Value will become value minus 3, that is 35 minus 3, 32. So when I will do Angela.age, so 32 should be printed, and yes, 32 is printed at the end, right? So basically what we are trying to do here, we are trying to write getters and setters on our own. By default, getters or setters are obviously always there, but here we are trying to do some extra piece of stuff using getters and setters. These are also not kind of heavily used, but yes, you must know what getters and setters are. Basically, getters are used for getting value of the property and setters for setting the value of the property. Moving ahead, Late init in Kotlin, it's very very important. I mean, in one of my interviews as well, I was asked about this. What is late init in Kotlin? Okay. So if you see here, I'd prefer explaining this with the help of one, practical code. So basically, late init, if you try to break it down, late meaning later, something which is done later on, and init means initialization, right? So it means we are somewhere telling the compiler or the system that I will initialize this late. Now I'm saying I will initialize this late. What is this here? So whenever we create variables, right? Whenever we create variables in Kotlin, so in the class they ask us to either initialize them, either give them some value, else they will throw error that the variable is not initialized, right? So if in case I don't know the value of the variable in the starting of the program, in the starting of the project, but later on maybe I'll give it some value, so in those cases I can put late in it. That hey, I will give it some value, I will initialize the name variable, but later on in the program, later on in the project. Let me quickly give you an example, and that will make things better and easy for you to understand. So let's say I'm taking this example only. Okay, I have the main function and I have the class person. Inside class person, if let's say I want to create one variable profession, okay, profession, so you can see it is throwing some error that property must be initialized. I should give it some value. This is of type string. Still it is throwing the value, right, that it must be initialized. But at this point I don't know the profession, right, and I don't want to keep it empty, so I can add here late in it, and the error is gone, right? Basically I told the compiler, I told the system that hey, I will give some value to profession, but later on, late in it, I will initialize it, but later on in the project. So later on when I'll feel like okay, I can give this value to profession, I can give that, right? So this is the use case of late init. If you break it down into two parts, late and init, it will become self-explanatory for you. Perfect. And now let's get back here and try to understand some more significant concepts. Let's talk about inheritance in Kotlin. Now let's talk about inheritance in Kotlin. Inheritance is one of the key features of object-oriented programming. It allows user to create a new class from an existing class. The existing class is called the base class and the new class is called the derived class. The derived class inherits all the features from the base class, and it can have additional features of its own as well. So for an example, let's say if you are creating a person class, or maybe if you are creating a vehicle class, a better example. So inside the vehicle class you can have not inside exactly, but if let's say let me write here, if base class is your vehicle, so you can have multiple derived classes that can inherit stuff from the vehicle class, like car, bus, truck, etc. All these are vehicles, right? So these can also be some classes which will be derived class of the base class, the parent class, right? So why inheritance is so important in programming, or in general in this language as well. So suppose in your application you want 3 characters: a maths teacher, a footballer, and a businessman. Since all of the characters are persons, they can walk and talk. However, they also have some special skills. A math teacher can teach maths, a footballer can play football, and a businessman can run business. You can individually create 3 classes who can walk, talk, and perform their special skill, right? Like math teacher, talk, walk, and teach math; footballer, talk, walk, and play football; and businessman, talk, walk, and run business. These 3 are the methods here. So in each of the classes, you would be copying the same code to walk and talk for each character. If you want to add a new feature, eat, you need to implement the same code for each character once again, right? This can easily become error prone, while copying or while doing duplication of code, etc. It would be a lot easier if we had a person class with basic features of a person like walk, talk, eat, sleep, and so on. And apart from that, if there are any special function, if there are any special feature of any character, any class, then you can add the extra function just in that class, right? This is done using inheritance. How? So this is now person class, the base class. It has the basic things that every person needs, like talk, walk, eat, sleep, and so on. Apart from that, you can have maths teacher class, play football class, run business, these maths teacher, footballer, businessman, these classes. And inside this you can have such method, teach math or run business, play football, etc. Basically what we are doing here is, person is the base class, and all these maths teacher, footballer, and businessman, all these are the derived classes. So instead of implementing these functions in each and every class, math teacher, footballer, businessman, what I did, I created a single class, that's it. And every time you will create something, you can just inherit a stuff from there, you can inherit these functions from there. So using inheritance, now you don't implement the same code, walk, talk, and eat for each class. You just need to inherit them, right? So for maths teacher, that is derived class, you inherit all features of person, and you add a new feature, teach math. Similarly for footballer as well, you inherit all the features of a person and add one more extra feature, play football. And same goes with the businessman class. This makes your code very clean and understandable and extendable as well. It's important to remember, when working with inheritance, each derived class should satisfy the condition whether it is a base class or not. In the above example, maths teacher is a person, every footballer is also a person. You cannot ask something like businessman is a business, right? I mean, obviously the concept is clear here. When you are creating subclasses out of the base class, it's important to understand that while working with the inheritance, each derived class, like maths teacher, footballer, businessman, each derived class should satisfy the condition whether it is a base class or not, right? So here is the example. Person is the class here, and then basically we are writing the same thing in code as well. We have class person, and inside this we can have multiple function. Then we have class maths teacher, which is inheriting stuff from the person class. This is also inheriting, this is also inheriting. This is the syntax of inheritance. If you are creating a class XYZ and you want to inherit from class base, so you will write something like this, and then inside curly braces you can add extra stuff for XYZ, right? So notice the keyword open before the base class person. The keyword open here is important. It's important. By default, classes in Kotlin are final. Final means cannot be changed or are constant, right? If you are familiar with Java, you know that a final class cannot be subclassed. By using the open annotation on a class, compiler allows you to derive the new classes from it. So if I remove open keyword, so you cannot create or you cannot derive things from here. I mean, you cannot use it as base class, okay? So you now know the significance of open keyword as well. So employee is one class. It is having name, age, salary as functions. Inside this you have some more classes, I mean some separate individual classes which are kind of deriving stuff, which are derived class of the employee base class. This is the base class here, and all these are the derived class. So these derived classes like web developer, Android developer and iOS developer, these derived classes will have all the features of the base class employee. They all will have name, age, salary, and apart from that, on top of that, they will have some special features of their own as well. Like web developer will know how to design website, they know how to design Android apps, and they know how to design iOS applications, right? So here is the example. You can take a screenshot of this as well. Let me tell you what we are trying to do here. So this is the main function T1. We are creating object of math teacher class. We are passing here 25 and Jack. 25 and Jack. Then I am saying T1 dot teach maths. So it will print I teach in primary class, right? I teach in primary class. And if you notice here, we are before that we have these two extra lines as well. My name is Jack and my age is 25. How and why it is coming, it's very important. It is coming because whenever you create object of this math teacher class, so obviously alongside the math teacher, it is a derived class of this base class person, right? Of this base class person. So here as well you are kind of passing 25 and Jack, and whenever the object of this class will be created, so obviously they have init block, and we know as soon as the object is created, the init block is executed. That's why we are printing this. And after that we are printing whatever is written inside the math teacher class. So when the object T1 of math teacher class is created, when this is done, T1 object of math teacher class is created, the parameters are passed to the primary constructor. In Kotlin, init block is called when the object is created. I just told you. Since math teacher is derived from the person class, it looks for initializer block in the base class person and executes it, right? Since the math teacher is derived from the person class, it looks for initializer block in the base class. In the base class, it tries searching for the init block, and it also executes it. If the math teacher had init block, the compiler would have also executed the init block of the derived class, right? Next, the teach maths function for object T1 is called using this statement. The program works similarly. When object F1 of footballer class is created, it will execute the init block of the base class, that is the person class, and after that the play football method is called using F1 dot play football. Same story is true here with this as well. If you create F1 object for footballer, then it will search for init block in the parent class. The parent class is person and the init block is this, right? So it will execute my name is this and my age is this, and after that we are calling F1 dot play football, right? So it's simple. It's just that you should know the theory part of it, right? If we are performing inheritance, then what is the order of calling which function when? If two init blocks are there, if the init block is in parent class as well as in the derived class, then init block of the parent class will be executed first, and after that the init block of the derived class will be executed, right? Important note for Kotlin inheritance: if the class has a primary constructor, the base must be initialized using the parameters of the primary constructor. So both derived classes have two parameters, age and name. So they are giving the they are explaining with the help of the example. So if you look at this example, F1 is the object. We are creating one object for footballer class, and footballer class is basically derived class of the person base class, right? Of the person base class, and footballer has init method of its own as well. So here the primary constructor of the derived class has three parameters. Primary constructor of the derived class has 3 parameters, right? Age, name and club. And the base class has 2 parameters, age and name. Note that both parameters of the base class are initialized. So when you will pass value for the footballer class, so this will also be initialized. Whatever value you are passing here, accordingly it will take values for the base class as well. In case of no primary constructor, each base class has to initialize the base or delegate to another constructor which does that. And here is an example of that again. Here they are using the concept of secondary constructor, and which once again is not heavily used in Kotlin, but you must know the significance of it, right? So if you look at the function main, we are creating p1 object for auth class, and we are passing here bad password, the value, right, the constructor. So here you can see we don't have any primary constructor. So in case of no primary constructor, each base class has to initialize the base using super keyword or delegate to another constructor which does that. So in this case, because no primary constructor was associated with auth, you can see in the constructor, in the secondary constructor, we are passing values, right? So that if we are giving values while creating the object, it can process it somehow, right? So by now you know the concept of inheritance as well, right? And now is the time we talk about Kotlin visibility modifiers as well. Earlier as well, you would have seen us using private, public, all those keywords, right? By default, all the variables, member functions inside a class are public, but yes, explicitly if you use private or protected keyword, then obviously they will behave that way. So visibility modifiers are keywords that set the visibility of classes, objects, interfaces, constructors, functions, properties and their setters. You cannot set visibility modifier of getters, as they always take the same visibility as that of the property. So these are visibility modifiers inside classes and interfaces. You can take a screenshot of this. Public, private, protected, internal. The words are somewhere self-explanatory. Public means visible to any client who can see the declaring class. Private means visible inside the class only. And protected means visible inside the class and its subclasses. And internal, visible to any client inside the module that can see the declaring class. Basically, you should have an overview of what these keywords are. And if you override a protected member in the derived class without specifying its visibility will also be protected. So yes, I hope all the concepts that we studied in this module are clear to you. We started with classes and objects, right, which are literally very important concepts in any programming language. We understood what are constructors, type of constructors in Kotlin, secondary and primary constructors, right? After that, we also understood the theory part of getters and setters, right? Getters and setters, late init, very significant keyword in Kotlin, late init in Kotlin. It is the keyword is self-explanatory, late init. Whatever we want to initialize later, not immediately, right? So if you want to create a variable and you want to give it a value later on, you can use the late init keyword in the class. And apart from that, we talked about inheritance. In Kotlin, which is very much same as in any other programming language. And then visibility modifiers as well, So yes, I hope these concepts are clear to you. And in the coming classes, in the coming modules, we'll be creating some exciting projects as well using the Kotlin programming language. So yes, see you in the next lecture. I hope this module was helpful for you. Make sure you like the video and subscribe to Scalar's YouTube channel for more such insightful content.